Hello students, welcome to my another lecture. I am Dr. Ashish Vikhar and today I am going to explain what are the different types of motions that we must know while studying the subject theory of machines. For such more videos, you can subscribe my YouTube channel Dr. Ashish Vikhar or you can hit my website drvikhar.com. Also, you can send your queries to my email ashishvikhar20@gmail.com. As today's topic is types of motion, so in that way you will see the figure in front of you showing the rectilinear motion, circular motion, rotational motion, periodic motion. So various types of motions that we must know in theory of machines because different mechanisms have different motions. In this particular lecture, we will learn about the meaning of oscillatory motion, rotational motion, translational motion, periodic motion, circular motion, linear motion, uniform motion, non-uniform motion. So such motions are of different types, but we must be able to differentiate among all these types of motion. Then and then only we can understand the physics behind the motion as well as the motions which are that we have to give to different links which are used in mechanisms. Before that, we must know what is meant by rest position of the body. A body is said to be at rest if it does not change its position with respect to their reference point. So here this is the most important before studying the motion. A body is said to be at rest if it does not change its position. Body does not change its position. So position is very important with respect to the reference point. The objects which remain stationary at a place and do not change their position are said to be at rest. For example, a table and chairs lying in a room are the state of rest because they do not change their position. So body is not changing their position with respect to the surrounding of the room. That's why the table and chairs lying in a room are said to be in the state of rest. After that, after knowing the meaning of rest position of the body, let us see what is meant by motion. The free movement of the body with respect to time is known as motion. Free movement. So here free movement is the word. Free movement of the body and with respect to time. So time is another parameter that is coming into consideration. In physics, so motion in physics is defined as a change in position of an object with passage of time. So change in position of an object with respect to or with the passage of time. The fan, the dust falling from the carpet, the water that flows from the tap, a ball rolling around, a moving car, etc. These are some of the examples of motion. There are various types of motion that are happening around us and they can be basically distinguished on the basis of four parameters: time, speed, one is time, speed, distance and path. So these are the four parameters which should be considered while defining the motion. Let us see the first type of motion, translational motion. Translation motion is the motion in which all points of the moving body move uniformly in the same line. All points of a moving body move uniformly in the same line or in the same direction. Then it is called as a translational motion. If an object is executing translational motion, then there is no change in its orientation relative to the fixed point. Let us see the examples of translation motion. A train moving in its track, a man walking on the road, birds flying in the sky. These are supposed to be the examples of translational motion. Another examples of translational motions are, first is a car or a train moving along a road or a track. Second example, a ball rolling on the ground. Third example, firing of a bullet from a gun. Fourth example is a stone hurled from a catapult. Then example is an apple falling from a tree. Next is a striker on the carom board going straight to hit the coin. So these are the several examples of translatory motion. So there are two types, or there are two kinds of translatory motion. One is called as a rectilinear motion and second one is called as a curvilinear motion. So let us see what is meant by rectilinear motion. In this picture you will see the point O initial position and point P is the final position, and distance between this is x. This is nothing but the x. So let us see by this figure what is the meaning of rectilinear motion. It is defined as a motion along a straight line. The position P, you will see that the position P of a particle on that line is defined by choosing a fixed origin O. So this is a fixed origin O and a positive direction. So positive direction is in this direction. The distance x, so here is this the distance x from O to P, from O to P with the approximate sign completely defines the position of the particle on a line. So in case of rectilinear motion, you will see that this is the initial position O, this is the final position P, and this is nothing but the distance between this. So object is possessing here rectilinear motion. So velocity v equals the time derivative of a position x. So v is nothing but dx by dt, and acceleration equals the time derivative of velocity v. So we can calculate here acceleration is nothing but dv by dt, or we can say d square x upon dt square, this derivative that we should consider while defining the acceleration. So acceleration also can be defined from this is a is equal to v into dv by dx. So in case of rectilinear motion we can define velocity acceleration like this. So when an object moves along a straight line like a ball dropped from the height, the motion described by the body is called rectilinear motion. Examples of rectilinear motion are a ball rolling on the ground, a car moving on a straight road, a stone falling freely, and a coin moving over a carom board. So these are the four examples of rectilinear motion. Then we come to know what is meant by curvilinear motion. When a body moves along a curved path, so curved path is there. The motion described by the body is called curvilinear motion. Let us see the examples of curvilinear motion. First example is a stone thrown by a boy from a height. Second example, a car moving along a curved path. Third example, a javelin or a shot put thrown by an athlete. Next is a ball thrown upward at an angle. A car or a train moving along a curved road or a track. These are some of the examples of curvilinear motion. Let us see the meaning of rotational motion. A motion in which body moves about a fixed axis. So fixed axis is there and body moves about a fixed axis without changing its position is called as a rotational motion. So this is a fixed axis and around that the body object moves like this. So without changing its position, but without changing in position, then it is called as a rotational motion. The examples are the motion of the blades of the fan, the wheel of a sewing machine, the motion of a giant wheel, a spinning top, a spinning wheel, charkha, which is called as a charkha, and a rotating potter's wheel. These are some of the examples of rotational motion. Then we come to know what is the combination of translatory as well as rotational motion. You will see a cyclist here is moving from one position to another position with his translational motion along with the rotational motion of the wheel. So it is called as a combination of translatory and a rotational motion. In some cases, the motion of rotation and motion of translation occur at the same time. So in this particular example, the motion of rotation and the motion of translation occurring at the same time. When a drill cuts through a metal piece, let us see another example. When a drill cuts through a metal piece, it performs the motion of translation as well as motion of rotation at the same time. Other examples of this kind of motion are the wheels of a moving bicycle, as you can see in this picture, or a car, and the ball delivered by a spin bowler. So these are some of the examples of translatory combination of translatory and rotational motion. So this way, in short, we can define or we can classify here types of translational motion. One is called curvilinear motion, another one is called rectilinear motion. Example of rectilinear motion is man walking on a straight path, and of curvilinear motion is nothing but a parabolic motion. Curvilinear motion can have along a curve, so curve is there, but in case of rectilinear motion, straight line motion is considered, and after that we can have linear in one direction, that motion is linear in one direction. But in case of curvilinear, it can be along a 2 or 3 dimensions and no rotation along a fixed axis. So this picture shows basic two types of translation motion. One is curvilinear and another one is rectilinear motion. So what is another after that, there is a difference between curvilinear and circular motion, but here we are understanding what is circular motion. When a body moves along a circular path, the way an athlete runs around a circular track, such motion is called circular motion. So another examples, the more examples of circular motion: motion of an electric fan, motion of a merry-go-round, motion of a spinning top, motion of the earth around the sun. So note that in circular motion, the position of the body itself changing with the time. Position is changing. But in case of rotational motion, the position of body does not change. You must consider the difference between this circular motion and curvilinear motion. Okay, it is to be noted that circular motion is a special case of rotatory motion. So here is a difference between rotational motion and circular motion. In case of rotational motion, body stays in the same place with moves and change its position with time. But in case of circular motion, body doesn't stay in the same place, it respect to the time. Next is in case of rotational motion, the body rotates about an axis, may not pass through the body. But in case of circular motion, the body along a path whose axis passing through it. In case of rotational motion, no linear motion is observed for the body as a whole. In case of circular motion, body may undergo linear motion. Let us see another motion which is called as a reciprocating motion. Reciprocating motion is the repetitive up and down and back and forth movement of an object. Examples are sewing machine needle, reciprocating pumps, doorbell ringer, reciprocating engines, movement in loudspeaker coil, shaper machine, power hacksaw machine. So another types of motions are uniform motion and non-uniform motion, and as per the direction we can have one dimensional motion, two dimensional motion and three dimensional motion. Uniform means constant and non-uniform means not constant. So this picture particularly shows by picture which are the types of motion. One is called linear motion. This symbol you will create here, that is showing linear motion. After that, reciprocating motion. This to and fro motion is nothing but reciprocating motion. Rotational motion like this. After that, oscillating motion like this. So fan is the example of rotational motion. Metronome is nothing but example of oscillating motion. Piston is the example of reciprocating motion. Train is the example of linear motion. Sewing machine is the example of reciprocating motion. Door is the example of oscillating motion. Pedaling is nothing but rotating motion. Sewing is nothing but reciprocating motion again. Cam and follower, it is nothing but the rotation and reciprocating motion. Opening and closing of a drawer, reciprocating motion. Tightening a bench wise is nothing but rotation and reciprocal, and door handle is nothing but rotation. So these are the various examples of different types of motion. Another concept is what is periodic motion. A motion repeats itself after an equal interval of time. For example, uniform circular motion. There is no equilibrium position. There is no restoring force. Restoring force is absent in case of periodic motion. What is restoring force? That will come to this point in the next slide. There is no stable equilibrium position. Another motion is oscillation motion. To and fro motion of a particle about a mean position is called as an oscillatory motion, which a particle moves on either side of equilibrium. Mean position is an oscillatory motion. It is a kind of periodic motion bounded between two extreme points. For example, oscillation of simple pendulum. This is an example of oscillating motion. Spring mass system. The object will keep on moving between two extreme points about a fixed point is called as a mean position, equilibrium along any path. In an oscillatory motion, the net force on the particle is zero at the mean position. The mean position is a stable equilibrium position. There will be a restoring force directed towards equilibrium position or mean position. Now this is a very important simple harmonic motion. Our cam profile design is depending on one of the parameter which is called as a simple harmonic motion. It is a special case of oscillation along a straight line between the two extreme points. What is the characteristic? Path of an object needs to be a straight line. There will be a restoring force. So restoring force is considered in case of defining simple harmonic motion, and this force directed towards equilibrium position or mean position. Mean position is a in a simple harmonic motion is a stable equilibrium. For instance, have you seen a pendulum? When we swing it, it moves to and fro. So that pendulum moves to and fro along a same line. These movements are oscillations. Oscillations of pendulum are an example of simple harmonic motion. Now consider there is a spring that is fixed at one end. So this is a spring that is fixed at this end. When there is no force applied to it, it is its equilibrium position. Now if we pull it outward, there is a force exerted by a string that is directed towards the equilibrium position. And if we push the spring inward, there is a force exerted by the string towards the equilibrium position. In each case, we can see that the force exerted by the spring, is towards the equilibrium position, mean position. This force is called as a restoring force. So this restoring force is considered while defining the simple harmonic motion. Now let the force be the F. This is a force F, and the displacement of the string from the equilibrium position is x. So this is nothing but the displacement x. Therefore, the restoring force F is equal to minus kx, minus k into x. The negative sign indicates that the force is in opposite direction. Force will be in opposite direction. That's why this minus sign is given. Here k is the constant called as a force constant. Its unit is Newton per meter, or in SI system dynes per centimeter. Newton per meter in SI system and dynes per centimeter in CGS system. So let us define here by this figure what is meant by simple harmonic motion. Simple harmonic motion in physics is nothing but a repetitive movement back and forth through an equilibrium or a central position, so that maximum displacement on one side of this position equal to the maximum displacement on the other side. So this point should be get under consideration. Maximum displacement on one side of this position is equal to the maximum displacement on the other side. The time interval of each complete vibration is the same. Simple harmonic motion is defined as motion in which the restoring force is directly as we have seen in the last slide. Restoring force is directly proportional to the displacement of the body from its mean position. The direction of this restoring force is always towards the mean position or equilibrium position. The acceleration of the particle executing simple harmonic motion is given by a is equal to minus omega square xt, where omega is the angular velocity of the particle. Simple harmonic motion is the motion in which the object move to and fro along a line. In short, we can say like this. So what are the types of simple harmonic motion? There are two types. One is linear SHM and another one is angular SHM. Linear simple harmonic motion means when a particle moves to and fro about fixed point along a straight line, then its motion is called linear simple harmonic motion. For example, spring mass system is nothing but the example of linear simple harmonic motion. Angular simple harmonic motion, when a system oscillates oscillates angular along the respect to the fixed axis, then its motion is called angular simple harmonic motion. Amplitude of, let us see how to calculate the amplitude of SHM. What is amplitude? It is the maximum displacement of the particle from the mean position. You can see in this picture, this is amplitude A. So this is a mean equilibrium position, and this is the extreme point, and these are the two extreme points. So you can have this amplitude A. So let us see how to calculate time period and frequency of simple harmonic motion. The minimum time after which the particle keeps on repeating its motion is known as time period. The shortest time taken to complete one oscillation is also defined as the time period. So T is equal to 2 pi upon omega. After that, let us see how to calculate frequency. The number of oscillations per second is defined as the frequency. So frequency is nothing but 1 upon T, and angular frequency is nothing but omega equal to 2 pi f equal to 2 pi upon T. T is nothing but time period. So here is the difference between the periodic motion and simple harmonic motion. In case of periodic motion, the displacement of the object may or may not be in the direction of the restoring force. But in case of simple harmonic motion, the displacement of the object is always in opposite direction of the restoring force. Also, in case of periodic motion, the periodic motion may or may not be oscillatory, but simple harmonic motion is always oscillatory motion. Periodic motion examples are the motion of the hands of a clock, the motion of the wheels of a car, while simple harmonic motion, the motion of pendulum and motion of the spring. So these are the points of differentiation between periodic motion and simple harmonic motion. Thank you very much.